Welcome back. Thank you for taking the time to view this presentation. My name is Mike Strong and I am a physical security design engineer with TrueSys. This is design tip 2, using 3D design tools to maximize performance and minimize cost. The next in a series of physical security design tips that we hope will enhance the security designs of your projects. I promised in our previous presentations that we would do a deeper dive into using 3D design tools for physical security in Revit and in SketchUp. So let's begin. Here is the task. I am using the Axis plugin for Revit 2019. We have our main entry doors and a reception desk, and cameras viewing it from each side. The operational requirement is identification. An operator should be able to identify an unknown subject. We saw from our last discussion that a pixel density of 76 pixels per foot or 250 pixels per meter is required. We want to see if we can achieve these results with the device selected, a 2 megapixel dome camera. I've displayed the field of view for camera 1. See this darker blue arc? This represents the limit of 250 pixels per meter density. And now for camera 2. Here is our 250 pixel per meter arc, and it extends just past the reception desk. It appears that we have the proper pixel density in the area of the reception desk. Since this is Revit, we can also display in 3D. Here's our field of view and the limitation of our arc past the reception desk. This plugin also allows us to see simulated camera views. Here's camera 1. A good unobstructed view of the desk, the far wall with the man traps and bypass door. Here is camera 2. Again, a good view of the desk and the opposite wall and double doors. I've also placed other cameras as alternatives. Maybe we can get a better view of the entry door. Here's camera 1A. A good view, and we can see the entry doors. However, we lost the view of the bypass door on the far wall. Here is camera 2A. Again, a good view of the desk area, and we still see the far wall, a slight blockage occlusion of the entry doors. What about aesthetics? We can see geometry for devices in the model and make choices. Here we have a surface ceiling mount dome, and here we have a recessed ceiling mount dome. Here are wall mounts, a surface mount wall camera, and a camera on a wall bracket. We can also look for clashes and issues. Camera 3 is set to view this double door. However, a light fixture is blocking its field of view. Point is, one can model and determine the optimal selection and placement of devices. Let's go back to camera 2A for a moment. It's viewing a glass entry door. Will this sensor need a good high-performance dynamic range to mitigate backlighting effects? We can examine conditions, view, and adjust. If requirements change, you can make those changes and better understand the impact, all by working in the 3D model. Better to do it here where there is no impact to cost and performance. What's the old expression? Measure twice and cut once? Well, we can measure and view as many times as we wish in order to get the best design. We can also create models and do the same analysis with SketchUp. You can either export a 3D CAD of the entire model or a section and import to SketchUp, as I've done here. I've also placed a few human figures for reference. Using the Axis extension plugins for SketchUp, we just select the device that we want from a toolbar and place them in the model, then adjust the properties for that device. I've already placed a couple of cameras here and here. If I select them, I can then turn on the field of view for the camera. As we see, the darker teal area represents our area where we achieve, in this case, 76 pixels per foot, which extends, just as in Revit, just past the reception desk area. This plugin also allows us to see a simulated camera view. I'll turn off the camera fields of view, and we'll take a look at camera 1, and now camera 2. Here is a warehouse type environment. We have a pan-tilt zoom camera on the wall, and we can see its field of view. Let's take a look at its simulated image. We can also use the pan tool to pan through the scene, looking for problem areas, things that might be hidden, things we would want to change. We have been examining the use of these tools for video sensors. However, any sensor device may be represented and its effective field of detection could be shown. For example, here is some geometry representing a 360-degree motion detector that could be suspended from the ceiling by a pendant, and then showing its effective field of detection. We covered using the Axis plugin for Revit, how to design and evaluate achievement of operational requirements, looking for clashes and issues, getting a preview of the aesthetics of the design, using SketchUp and the Axis extensions to perform many of the same tasks and more. We saw the value of working in a 3D environment where we can plan, do, check, and act as many times as we wish at virtually no cost so that we can perfect the design. Finally, going beyond the available tools and creating our own graphic representations of devices. For more information, watch for our next video, Physical Security Design Tip 3, Reviewing the Design Process. Please also feel free to contact me, Mike Strong. From all of us here at TrueSys, thank you for your time, and as always, have a great day.